My name is Taranija, and you're watching Brain Security. We are solving the advent of cyber by TryHackMe, and today's topic is Web Attack Forensics Drone Alone. Let's get started with the story. TBFC's drone scheduler web UI is getting strange. Long HTTP requests containing base64 chunks. Splunk raises an alert. Apache spawned an unusual process. On some endpoints, these requests cause the web server to execute shell code, which is obfuscated and hidden within the base64 payloads. For this room, your job as the blue teamer is to triage the incident, identify compromised host, extract and decode the payloads, and determine the scope. You'll use Splunk to pivot between web Apache logs and host level Sysmon telemetry. Follow the investigation steps below, each corresponding to a Splunk query and investigation goal. Learning objectives: detect and analyze malicious web activity through Apache access and error logs, investigate OS level attacker actions using Sysmon data, identify and decode suspicious or obfuscated attacker payloads, reconstruct the full attack chain using Splunk for blue team investigation. Now you'll use Splunk to pivot between Apache logs. Apache is the server over here, widely used web server software, and Sysmon is System Monitor, which is a Windows system service and device driver developed by Microsoft that is designed to monitor and log various events happening within the Windows system. It is Windows System Security Service that enables logging each and every incident in the form of parent image and child image. That means parent image tells you which processes were created by the particular process that we're looking for. We will explore that further in the room. And let's start with the theory part. Yes, we will need to log into Splunk first. So we will start the machine. Meanwhile, what do we have to do here? First, we will go to the Splunk dashboard after the machine loads. Then we will check the default time range. If it's too short, we may see no results. Then a blue team would explore various attack angles via Splunk. In this task, we will follow elflog McBlue, who uses his Splunk magic to unravel the attack path. This is the second room for Splunk in the Advent of Cyber Challenge, and that is why certain things were already covered in the first video, where they just introduced us to what Splunk is, how it is used, and just got us familiar with the interface of Splunk. And we wrote some SPL, that is Splunk Processing Language, SPL queries, and yes, got some basic things done. Detect suspicious web commands. In the first step, let's search for HTTP requests that might show malicious activity. So let us first see what has exactly happened. Um, there has been something notified by Splunk, and we have to also see the Sysmon logs. HTTP requests that might show malicious activity. The query below searches the web access log for any HTTP request that includes signs of command execution attempts such as cmd.exe, PowerShell, or invoke expression. We have to run this SPL query and check HTTP request for such command execution attempts. Now there is something called command injection attacks, just like SQL injection attacks, in which the input fields are exploited and the SQL query is injected into the input area, and you possibly try to run a database query on the server end. You possibly try to run that SQL command through that input box. What happens in command injection attacks? We have in a URL, we have something, for example, if you have www.google.com, a slash and a question mark, that is not question mark. Now over here, you can put parameters, right? I mean, those are handled by the developers, but that is how the architecture works. So in that particular parameter, you tell the server that run this particular command for me. That is command execution. You tell the web app to run OS level commands, which are highly not desirable. We have username and password. Username is blue. That is pass 1234. We will first check for the time range last 24 hours. Let us increase it to last 7 days or all time. Let us go for all time and search using this query index. Search for Windows Apache access and search in the logs using this particular keyword called Windows Apache access and see if cmdx.exe, PowerShell or PowerShell exe, any of this has been called for. Show me table time, host client IP, URI path, URI query state. We have the results displayed here. This is the IP. Oh, no, this is the table time. This is host. This is IP, client IP. Now, there has been few requests regarding cmd PowerShell.exe. That means there has been some command injection occurred through the HTTP request. At this step, we are primarily interested in base 64 encoded strings because there is some gibberish data that we can see from here. Let us try to decode it using base 64. Let us wait and check again. Yes, it told us to go over here and check for this particular string. I might have made a mistake in copy paste. This is now mine. Ha 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 ha. So the attacker was trying to see if that particular command would work or not. Now we will see if that thing actually ran on the server or not. Looking for server-side errors or command execution in Apache error logs. In this stage, we'll focus on inspecting web server error logs as this would help us uncover any malicious activity. We will use the following query. It's very helpful that they provide the entire query. This is beginner level. They try their best to help us out. There has been 3 logs that say that PowerShell command was called for. This query inspects the Apache logs for signs of execution attempts or internal failures caused by malicious request. Now, what description does this give us? Not recognized as an internal or external command. There has been this request Apache 24 CGI bin hello.bat. There is this one file that it found out called hello.bat, and probably they are trying to inject some code inside this file to probably gain access to your system or break into your system. Please make sure you select view raw. View list, we will go with view raw from the drop down menu. Now, October this, process ID is this, client. Over here, they have given this example. Now, this question mark stands for the parameter that you can pass while you go to this place, that is the URL. It triggers an internal server error. It often means that the attacker's input was processed by the server but failed during execution, a key sign of exploitation attempt. You have to restrict certain operations in your backend servers. Trace suspicious process creation from Apache. Let's explore Sysmon for other malicious executable files that the web server might have spawned. We will do that using the following Splunk query. We first examine the web access logs and then we went to the server side and checked if there has been any internal server error or not, because these kind of logs indicate that some attacker has been there. Traces. Now we will run this query. Finally, we are seeing that what logs have the system recorded while all of this has happened. Very detailed log. Data command line, parent name command line, http.exe, that is a normal process, data name parent user, parent image is this, and the child image or the image is set to be cmd.exe, which is not suitable. It indicates a successful command injection where Apache executed a system command. Command injection is a vulnerability that occurs when an attacker manipulates input fields to inject malicious code into a vulnerable application. This can lead to unauthorized execution of arbitrary commands on the target server, potentially resulting in data breaches etc. etc. The finding above is one of the strongest indicator that the web attack penetrated the operating system. Confirm attacker enumeration activity. In this step, we aim to discover what specific programs we found from previous queries do. In this step, we aim to discover what specific programs we found from previous queries do. Let's use the following query. The attacker usually tries to run this whoami command to see if whatever actions they have performed has enabled them to gain the root access to the system or not. So after execution of such commands, if this command is found whoami, then you can directly say that attacker has been there. Determine which user account the malicious process is running on. Finding these events confirm the attacker's post-exploitation reconnaissance, showing that the injector command was executed on the host. Identify base64 encoded PowerShell payloads. In this final step, we will work to find all successfully encoded commands. To search for encoded strings, we can use the following Splunk query. This query detects PowerShell commands containing encoded command or base64 text, a common technique attackers use to hide the real commands. Now, if they don't want the system to directly recognize what you have run, they will encode it with the base64 format. So let us try to find that. If your defenses are correctly configured, this query should return no results, meaning the encoded payload, such as something, never ran. We didn't get anything. What is a reconnaissance executable file name? What executable did the attacker attempt to run through the command injection? Executable did attacker attempt to run through the command injection? We have PowerShell.exe. That is the answer for second question, I think. Reconnaissance executable file name. This matches the word here. Should be the answer. So yeah, that is it for today. See you in the next challenge.